Morning, everyone. We'll just do our usual, give 30 seconds to a minute, let the last few follow in, and we'll get going. Okay, I think we have a good shot in, and we'll get going for those of you that are here. Thank you for joining us this morning for this webinar using shift register functions. The presentation's roughly about 18 minutes, and if you have any questions at any point, you can put them into the panel and we'll get to them at the end. We'll get started.
Welcome to today's tutorial. Let's get started. Let's take a look at today's agenda. We'll look at the definition of a shift register. We'll discuss various shift register functions, including the multi-shift instruction and the rotate instruction. We'll go over some real-life applications of shift registers with live demonstrations. And as always, we'll finish with a live Q&A session. So what is a shift register? In digital circuits, a flip-flop is a device that's used to store a digital binary value. If you cascade a series of flip-flops in a chain, connecting the output of one to the input of the next one in the chain, you now have a shift register if they all share the same clock signal. Shift registers allow data to be shifted to the left or to the right. They are often used for data storage and for the movement of data. In digital circuits, shift registers strictly store and move binary data. In Cscape, the multi-shift function can be used with many different data types. There are many configurable parameters with the multi-shift instruction. Firstly, the source is the variable array containing the data you're managing. The length is how many bits, bytes, words, or double words that are in your shift register. The n parameter is the number of positions to shift when we execute the instruction. The direction field determines which direction you shift. When you shift left, you're shifting from lower significance to higher significance, and when you shift right, you're doing the opposite. The in parameter contains the data that you're shifting into your shift register, and the out parameter is the data that you're shifting out of your register. Let's take a look at our first example of a multi-shift instruction. We've assigned a source to a variable array called widget storage. It's a variable array with a dimension of 8. There are 8 bits because we've assigned a bit type to this instruction. We're going to shift by one position when we execute the instruction. The direction has an always on contact assigned, which means we're shifting to the left. The input that we're shifting in from a widget sensor could be a photo that's detecting whether there's a widget present or not. What we shift out from our shift register position is a variable called widget output. The blue boxes contain the current states of data within widget storage. 0 is shown on the right, the last element in the array of 7 is shown on the left. The widget sensor input is on the right, and the widget output is on the left. Now we'll do a shift to the left. When we shift left, the input gets moved to the first element. In this case, the last element, which is 0, gets shifted to the output. All other positions move from lower significance to higher significance. Back to our initial state. To shift it right, we need to assign a 0 to our direction variable. In this case, our input goes to the last element. The element getting shifted out is 0. Multi-shift is not just useful for binary data. We'll show this on the next example. Here, we've assigned another multi-shift function. This time, we have a word data type and we're using integers. Our source is a variable array called testSample. It has 8 elements, with a 9th element added for the output. Again, we're going to shift by 1, starting by shifting to the left. The data we're shifting in is a variable called process temp, and the output we're shifting to is the same variable as our source. Let's shift that left. When we shift left, we take our input value, move it into element 0, the very first element, then we take the last element, element 7, and move it to the output. And then everything else shifts. Let's go back to the initial state. So this is how our data started. Now we're going to shift it right. This time our input value goes into the last element, and the first element falls off the end of the shift register and gets copied to the output. Let's start talking about some applications where this could be useful. We're going to discuss a use case where we're going to configure an OCS to record pressure readings from a sensor at the fastest possible speed and then graph those results on the screen. By using a multi-shift instruction, I can build a ladder routine which allows me to record data every single scan for a certain number of scans and display it on the screen. To do this, we need to put a push button on the touchscreen to allow us to initiate the test. The ladder logic will clear the test data and reset the sample counter. It will then record a set number of samples on consecutive scans using the multi-shift instruction. When it's finished, it will display the test results on a screen using an XY graph instruction. So what direction should you shift when storing your data? If we're shifting left, where the direction input is on or a 1, it'll take our input value and put it into the first variable position. Every subsequent time that we shift in additional data, it's going to move further away from the beginning of the data. So the first piece of data that we log is in the last position of our variable storage array. The data is in reverse order. If we shift right with a direction input of 0 or off, it'll place our input in the last position of the array, and then subsequently shift it closer to the beginning. Once we finish shifting, the first sample we took will be at the beginning of the array. Let's demonstrate using multi-shift for data storage in Cscape. So I'm in Cscape. We're going to start with a push button on the touchscreen. I've configured it to trigger a one-shot or a positive transition coil. That's for a few reasons. I want to reset my sample counter. In this example, I'm going to be shifting my shift registers 750 times on 750 consecutive scans to record 750 pressure values. Since I'm going to be counting those samples, I need to reset that counter to 0. And then I'm also going to fill my test array of 750 words, all with a value of 0. So this instruction will write a 0 to every member of the test sample array, starting from 0 and ending at index 749. When I'm done with that, I'm also going to clear my test complete flag, which may have been set from previous tests. Next, I want to delay the start of the test for a couple of seconds so that I have time to manipulate the data to show up in our demo. So I'm triggering a 2-second timer with that same one shot, but that one shot is going to turn off. So I've got to keep this timer timing. And to do that, I'm using the timer active flag, which is the 15th bit of the flag register for the timer. Once the 2-second delay has occurred, I'm going to set another flag to run our test. And this bit is going to turn on and it's going to stay on for the duration of the test. So this is our test run bit. That's going to stay on for the duration of the test. Every time we execute this rung, we're going to add 1 to the sample count. So starting at 0, the first sample is going to be 1 because we've added a 1 to it. And then we're going to execute our multi-shift. Let's double click here and see how we've configured it. So here's our array. In this case, it's a variable array called test_sample, and there are 750 members in the array. We're going to allocate those 750 members here. Every time we execute the instruction, we're going to shift by 1, and we're going to shift them to the right so that we get them the right way around. The input that we're going to be shifting into the shift register is called test_pressure. And then, if anything falls out of the array, is going to be copied to multi-shift out. In this case, because we're clearing all the values to 0 at the beginning, the only thing that gets shifted out every time we shift is a bunch of zeros. Okay, so that was the details of our multi-shift function for this application. Alright, so after we execute this for the first time, we now have our input stored at the end of the array, and then we're going to continue to execute this on 750 consecutive scans until our sample count is equal to 750. At that point, our test is complete, and we can turn off our test run indicator. So that's the logic that's involved in sampling a pressure value 750 times as fast as we can. Alright, let's go to the Cscape graphics editor and look at what it looks like on the screen. Okay, now we're in the graphics editor. Here's my start button that I've configured. I've got a running indicator that's going to turn on when the test is in progress. For convenience, I put an indicator on the screen that shows the current pressure, and then I have a jump button to get me back home as I need to. And then this is an XY graph. Okay, so I'm going to double click here and show you how that's configured. We'll be looking at a series of consecutive values with the XY graph. The first thing we'll configure is a trigger bit. When this bit turns on, that's when the graph is going to display data. Now, you can configure how many values you want to plot. In this case, it's 750, which lines up nicely with my array. And then the only other thing to configure is the data that you want to graph, and you can do that from the pens option here. Alright, and this is where we plug in our variable at the start of a variable array, which is test_sample, and the first member of that array is index 0. We are going to use all 750 members of test_sample, starting at 0 and ending at 749. And that's going to happen whenever the test complete bit turns on in our ladder logic. And remember, the test complete bit turns on at the end of the logic that we wrote to capture the data over 750 consecutive scans. So that's what it looks like on the screen. Let's take a look at the OCS in real time. Here we are in the OCS showcasing the screen we just configured. I'm going to get ready to initiate the test. Alright, there we go. The data is logging, so there is a look at our test. You can see that our value started out low, it dove to minimum, and then started coming up again. Let's try that again with a second capture. So I'll run a test again, and this time we ended up with the pressure going up to maximum and then going down again. So when I press this button here, after 2 seconds, our sampling starts happening, and then it takes samples until we reach 750, and then when that's done, it displays it on the screen. So that was using multi-shift for data storage. Now we'll discuss the rotate instruction. This is similar to the multi-shift, but it's simpler. This will rotate data in a circular fashion. Let's take a look at the parameters of the instruction. Source is the same as multi-shift. It's the variable array containing the data that you're going to be rotating. Length is the number of elements in the array, and is how many positions we're going to rotate every time we execute the instruction. And direction is the direction that we're going to rotate. If that input is on, we rotate left, and if it's off, we rotate right. It doesn't have an input or an output, and that's because you're not shifting data in or out, you're shifting data in a circular fashion. Let's look at an example here. We've got a rotate instruction set up for bit type with a variable array called machine_position as the source. It has a length of 8, it's an array with a dimension of 8, and we're going to rotate by 1 position every time. The direction we rotate is dependent on the direction input. If it's on, we're going to rotate left, and if it's off, we're going to rotate right. Here's our initial data. You can see the 8 data elements of the machine position binary array. As we rotate left, everything goes to the next position left from where they are, moving from least significant to more significant. And then the last element rotates back around to the first element. It's more straightforward than using shift registers. This time, let's rotate the other direction by changing our direction input to off. When we do that, everything shifts right from more significant to less significant, and then the first element rotates around to the last element. Now let's discuss some applications for using rotates. This example is about representing data movement as parts move in a machine. We're going to configure an OCS to display the status of the parts on a piece of rotary equipment. So in this example, we'll create a variable array that represents whether there's a part present on each station of a rotary machine. We'll also create variable arrays for push buttons that we can put on the screen to either load or clear a part from any particular station. We'll create push buttons to rotate the machine, either clockwise or counterclockwise. Lastly, we'll create a user screen to show the status of the machine. Now, we'll demonstrate using rotate for data movement in Cscape. So we're in Cscape. We'll start by going to the graphics editor to look at a graphical representation of our rotary machine. And each of these indicators here indicate a position on the machine. So if this position is red, then it's going to indicate that there's no part present on that station. If it's green, it means we've got a part that's present. If we want to load a part onto the station, we hit the load button. If we want to clear or remove the part from that station, we hit the clear button. Every location on the machine has a load and a clear button. To rotate everything, we've got a clockwise rotation button and a counterclockwise rotation button. Alright, now let's go back to the logic and see some of the supporting logic behind these graphics. Here's the rotate clockwise push button and the rotate counterclockwise push button that we have on our touchscreen. When we press the rotate clockwise push button, we want the direction to be clockwise. If we look down at our rotate instruction, we can see that the direction input is the rotate direction clockwise bit. So if we hit the clockwise bit, we're going to shift left, which is going to move things in a clockwise direction. If we press the rotate counterclockwise push button, we clear that bit, setting 0 into our rotate instruction. We want to rotate one position only, regardless of direction. So we are using a positive transition one-shot coil. The instruction will execute as long as it has power flow, so one-shots are very useful if you want them to execute once. Okay, now finishing up the setup for our rotate instruction, there's our variable array called machine_position, which has 8 positions. It's an array from index 0 to index 7, and we're going to shift exactly once every time we execute our instruction. Down here at the bottom, we have some logic which takes the load push buttons that we press on the screen and loads the appropriate bit on the machine. And then we have the same thing for clear. Now let's look at this in the OCS. So we're in the OCS. Right now, we have a machine that's completely empty. Let's load parts up in a couple of positions. So now you can see that we've got parts in 2 of the positions. Let's rotate the machine clockwise. And you can see that every time that we hit either the clockwise button or the counterclockwise button, the data will rotate. We can also clear the data with the clear data button. So that was a demonstration of the rotate instruction, and that concludes today's tutorial. Thank you for attending today's tutorial. The Q&A session will begin shortly.
Okay, just the one question I see so far. Where can we find the multi-shift block? In the project toolbox, if you go under move instructions, you will find it there. And just to add to that, if you're unsure and forget bits of the video, you can go back to the video. But also, if you double click on the block and press F1, it will take you to the section of the help file containing more info on that. So just some extra info. Don't see any other questions as yet. So I'll drop you back to the screen. Okay, you should see my screen now again. So we have updated our webinars page, so it's got a slightly different look to it at the moment. So now all our upcoming videos, you can click on the info, you can get a general read of what's going to be in the video. As always, you can register. The start time, it's just showing our local time in Ireland, so it'll be the same time as it has been every Thursday. It's just changed to our time there, so it'll still be the same time every week, depending on where you are in your time zone, but it'll be the same time as it has been. And as always, if there's anything you want to come back and rewatch, they're always available down here in the past webinar section. I'll just have one last look for questions. No, nothing else in. Okay, thank you for joining us this morning. We do have analog I/O scaling next week, so we hope to see you all for that and the future ones. But yeah, thank you for joining us this morning, and we'll see you again.